Okay, in this video we're going to look at how we solve compound inequalities. And there's two different kind of concepts that we'll use in this lesson. The first is when we have a typical compound inequality joined with an or an and, all we're going to do is solve each of the inequalities individually. And you'll see that in example A on this page. We have a typical compound inequality joined by an or. When we have compound inequalities that are written as one string, like in example B, we're going to take a slightly different approach, but still a fairly simple one. All right, let's look at example A. In this case, since we have two simple inequalities separated by the or, we're just going to solve each one individually and maintain the or in between them. So I'm going to add 5 to both sides in the first inequality, and then divide both sides by 3, and we get x is greater than 4. And in the second inequality, I'm going to subtract 4 from both sides, and divide both sides by -2. And now I'm going to join these, since we started out here with an or statement. The two solutions that I get are going to be joined by an or. And these are the solutions to this compound inequality. X is greater than 4 or x is less than -2. All right, now, with the string inequality, normally when we solve equations and inequalities, we add the same thing to both sides or subtract the same thing, multiply, divide by both sides. Now here, what we have, instead of having two sides to the equation, or inequality, pardon me, is we have 3 parts. And so what we do to one part of the inequality, we want to do to all 3 parts. So we look at the portion of the inequality that contains the x, and we want to work to isolate that x. And in order to do that, the first thing we want to do is we want to subtract 4. So what am I going to do? I'm going to subtract 4 from all 3 parts of the inequality. So -12 minus 4, 4x plus 4 minus 4, and 24 minus 4. And so we subtracted 4 from all 3 parts. And now we want to divide all 3 parts by 4 in order to get x by itself. So we divide the -16 by 4. We divide the 4x by 4, and we divide the 20 by 4. Whoa. And we end up with -4 is less than x is less than or equal to 5. Which, remember, that means that x is greater than -4 and x is less than or equal to 5. All right, a few more examples, and in these we're going to graph our solution sets as well. So solve and graph the compound inequalities. First one, I'm going to subtract 3 from both sides and divide both sides by 2. Second inequality, I'm going to subtract 2 and divide both sides by -3. Remember, when we divide by a negative, we want to flip that inequality sign, and so we get that. And now our solution is x is less than 2 or x is greater than, x is less than -2 or x is greater than 2. If you think about it, x is less than -2 looks like this. X is greater than 2 looks like this. Since it's an or statement, I want anywhere where one of those is true. So I'm going to end up with 2 open circles here and shading everywhere where one of those 2 inequalities is true. All right, part B, we have a string here. I'm going to first distribute the -2. And now I want to add 6 to all 3 parts. And now I'm going to divide all 3 parts by -2. Now remember, when we divide by a negative, we have to flip the inequality sign. And since we have 2 inequality signs here, I'm going to flip both of them. 18 divided by negative 2 is negative 9. Now, I normally would rewrite this so that it's in the typical order, because when I do it this way, it kind of shows me what my graph is going to look like. I've got a closed circle at negative 9. I've got an open circle at negative 7. And I'm going to shade in between those two. And there's my graph, my solution. All right, a couple more here. The first one, negative 2x minus 5 is greater than or equal to 3. I'm going to add 5 to both sides. Divide both sides by negative 2. And I'm going to subtract 6 from both sides. And divide both sides by 3. This is an and. So let's see, we've got x is less than or equal to negative 4, which looks like this. And we've got x is greater than negative 7, which looks like this. And we want where both of those are true. And so that's in between 2 points. And there's our graph of our solution. And one more example here. Add 5 to both sides. Divide both sides by 4. Subtract 5 from both sides. Divide both sides by negative 4. Make sure I flip my inequality sign, since I divided by a negative. And so we've got x is less than 4, which looks like this, or x is greater than negative 1, which looks like this. Since this is an or statement, I want to shade anywhere where either one of these is true. And if you look at it, that's everywhere. You know, over here, the inequality x is less than 4 is true. And over here, the inequality x is greater than negative 1 is true. And then in between, at least one of them is always true here. So every point on the number line ends up being in my solution of this inequality. All right, that's it for this video. See you next time.